let's solve the problem length of the longest increasing path. And it happens, it so happens that this problem is really easy if you've solved longest increasing subsequence first in the past, right? So we'll just look at this problem really quickly, and then we'll see the hardest problem. If you've done that several times in log n, you can just skip to the other problem. So the problem is really easy. This first problem is you've got an array and you want to return the length of the longest strictly increasing subsequence. So for here, for example, there are many strictly increasing subsequences, right? There's 10, 18. That's one subsequence that's strictly increasing. It's of size 2. And the longest one is 2, 3, 7, 101. 2, 3, 7, 101. Right? You can't swap them, right? A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. And to solve this problem, the idea is you will maintain an array. You have an array such that the length of this array will be the current longest increasing subsequence. And at position I, right, I'll get the smallest biggest number of increasing subsequences of size I, right? Maybe that doesn't make sense, but we'll just go through the algorithm on this list, right? It's just kind of a standard algorithm, more than one you probably can come up with, or at least I couldn't come up with this when I first solved that problem. So first, we'll just put 10 in our list, right? The length, because we're here, the length of our list is 1, so the current longest increasing subsequence we have is 10, and the smallest biggest number of increasing subsequences of size 1 is 10. Then we arrive at 9, right? We get to 9. 9 is smaller than 10, right? So we can't really make a subsequence of size 2, but the subsequences of size 1, right? There's two of them, either just 10 or either just 9. Which one of those has the smallest, biggest number of increasing? Maybe that wasn't clear. Smallest, biggest number in the increasing subsequences of size I. So here I have two increasing subsequence of size 1. Who is the smallest, biggest number? Right? Well, that's 9. Right? Because the bigger number here is 10, the bigger number is 9 here, and which is the smaller is 9, right? So my list is now not 10, it's just going to be 9, right? Let's go again, and it'll make more sense. Then 2, well, I can make an increasing subsequence of size 1, and the biggest number in that subsequence will be 2, so that's better than 9. So I just replace this by 2. Then I've got 5. Well, now I can do a subsequence of size 2. Instead of removing the 2, I'll just say now I have 2 and 5. Why? Because the length of my array is now 2, and the current longest increasing subsequence I can have is 2. And I want to keep in mind that if I want to make a subsequence of size 1, well, the minimum bigger number in my increasing subsequence of size 1 is 2, right? And now, and you'll see why it's useful, I get to 3. Right? 3 is not bigger than 5, but 3 is bigger than 2. So I can make 2 subsequences of size 2. I can either do 2, 3 or 2, 5, right? And I want to update my 5 as 3, because the smaller it is, the better it is, because the more room I'll have for longer subsequences, right? So it'll become 2, 3. And then 7, right? 7 is bigger than 3, so I can finally make a subsequence of size 3, and then I'll get 2, 3, 7, 101, and finally 2, 3, 7, 18. And my array, the length of my array at the end will be 4, and I will just return the length of the array. right? Let's implement it. Maybe it'll be easier to understand. So I'll make an array that I'll call current smallest biggest number in subsequence, right? And initially I just put num0, right? Because the bigger number I can get in the subsequence of size 1 if I only consider the first number of nums is obviously num0. And then I iterate over the array. And when I iterate, I want to check, right? I want to check, am I bigger than the last one, right? That's the first thing I want to check, because if I'm bigger than the last one, then I can make an even longer, subsequence. So that's interesting. So the first thing I check is if nums I is bigger than current smallest bigger than the sequence, the last element, then I'm quite happy, and I'm just gonna append my number, right? Otherwise, what do I do? Well, otherwise, sorry, if I'm not bigger than the last element, I gotta check who I could improve, right? Here I had 2, 3, 7, 101, and the 18 was better than 101, and it allowed me to lower that and potentially make room for a potential 34, for example. And so it happens that my array is always sorted, right? Just by construction is always going to be sorted, so I can just use binary search to find where this 18 would be in this array. And so that would be here. And then I could just replace my big number by my new smaller number, right? Again, going through it on more examples may be useful to you. So I encourage you to check more examples on this algorithm. So I'll do binary search. In Python, it's bisect.bisect.left. I want to look into this array, and I want to look for nums I in this array. Right, I look for nums I in this array, and so that's the index of the person I can improve. Right, and that's an integer. And then I'm going to replace this by my new number. And then I can just return the length of my array. Right, so that passes, and maybe I'll show a second examples just for good measure. Here I'm expecting 4 as well, so first of all, does it pass? Yes, and then we'll just step through the code with the debugger to just see what the state of the thing is. So initially I have 0, right? And then I encounter 1, so I can finally have a subsequence of size 2. So now I have 0, 1. Then I encounter 0 again. I can't make a longer subsequence, and so I'm going to try and improve the 0. Well, or just so happen that I can't improve it, but sometimes we can, sometimes we can't, so that's fine. And then I'm going to encounter 3. 3 is bigger than 1, so I can finally have a subsequence of size 3, 0, 1, 3, so I'm happy, I'll just add it. Then I encounter 2. 2 is not bigger than 3, so I can't make a better subsequence, but I can make 3 a bit smaller, right? And notice it's always sorted. So instead of 0, 1, 3, I can make 0, 1, 2, so that's better. So I'm just going to refresh it, make 2 instead. And that's good because now I have more room, right, to put the 3. If I hadn't replaced the 3 with the 2, the next 3 that's going to come now wouldn't have been able to allow me to get a longer subsequence. And now I have 0, 1, 2, 3, and then that's the end, and then I return just the length, and the length is 4. So that's just, you know, longest increasing subsequence. It's just a standard algorithm. You probably learned it when you learned how to sort arrays. That's very standard. And I really wanted to show this quickly because when you know how to do this, well, this problem is just really, really easy. So first of all, what's the problem? You've got an array of a two-day array of integers, right? And you're looking for, you have an integer k as well, and you want an increasing path, right? And it's in 2 dimensions this time, 2 dimensions. And if you've got 1, 2, and 3, 4, then you say, okay, 1, 2 can be before 3, 4. But if you have 1, 2, and 1, 4, for example, then you can't go through this one, then this one, right? Because xi has to be smaller strictly than xi1 plus xy plus 1. And yi has to be strictly smaller than yi plus 1. So that's not good. And you want to go through coordinates k. And you want to, you know, maximum length of an increasing path. Just reading this is a hint that we'll probably use what we just went over. So let's look at an example. Here k is 1, right? And so you have to go through the point 2, 2. And you can go through 0, 0, then 2, 2, then 5, 3, right? 0 is smaller than 2, 0 is smaller than 2, 2 is smaller than 5, and 2 is smaller than 3. Can you go through 3, 1, right? Well, the thing is, if you go to if you're at 2, 2, the point you have to go to, can you go to 3, 1? No, you can't, right? Because 1 is smaller than 2. If you are at 3, 1, can you go to 2, 2? Well, no, because 3 is bigger than 2. So those points are kind of like stupid points because you're never going to use them. Because if you want to go there, you can't go there, right? So there's loads of points we can just filter out, first of all. That's like a easy, fast simplification of the problem. Second sort of simplification is now we can just say, okay, I've got 3 points left, and this one I know I have to go through it before my 2, 2 point, right? And this one I have to go through after, right? So there's points I have to go through before 2, 2, and there's points I have to go through after 2, 2, right? And those points are just going to be longest increasing path without this weird constraint, right? So I'm just going to be able to apply the problem we just solved twice on those arrays. Note that these are 2-day arrays, so maybe I'll have to, you know, be careful. But let's first code this this simplification because we are simplifying the problem a lot. So maybe I need the input. First thing is filtered points before my first array. It's actually an array of it's a list of lists because it's a list of 2 elements, right? And filtered points after, and by after I mean after k, and by before I mean before k, right? I'm going to iterate over all my points, right? And if coordinates I 0 is bigger than coordinates k 0, so my xi is bigger than xk, and my yi is bigger than my yk, then I'm after. I have to be after. Filtered points after dot append coordinates I, right? Similarly, if I'm smaller, but both have to be smaller, then I'll go to filtered points before dot append coordinates I. Else, well, I don't do anything. Don't do anything because those points are stupid, right? Those are the stupid points I was talking to you about. Now we need to find the longest increasing path up to k and find the longest increasing path from k to the end. I made a mistake, sorry, typo. From path to the end. And this is where we will use longest increasing path, right? first of all, if filters points before is empty, then there's no point because there's no points before, so we'll just start a case, no worries. And if filtered points after is empty, similarly we won't do it. If it's not empty, we'll do something. If it's empty, then we'll just have k as our last point. And we'll sort the points. The idea is we'll sort the points, right? And we'll say with x0, right? Why do we do this? Well, the idea is if you want to find a path, it has to be 2, 2, maybe 3, 5, 4, 8, etc. It has to be sorted with regard to x, right? It has to be sorted with regards to y as well, but we can't do both at the same time. So let's just sort with regards with x, and then we'll sort out y. And now we have to sort out y. Well, now we can just look at those y points, right? I'll make an example. That's going to be easier. If I have 2, 2, then 3, 6, then 4, 4, then 5, 6. Those are sorted with regard to with x, but not sorted with regard to y, right? But if I only look at the y part, with regard to the constraints on x, I can do 2, 6, I can do this, then this, then this, this, then this, and this. I can do whatever because it's sorted with regard to with x. But now I just have to, I have to satisfy the constraint with y. I'm not allowed to do 2 and 6. So I can just look at y's, and I can notice that I'm looking for the longest increasing subsequence for this array, 2, 6, 4, 6, and the answer is 3, 2, 4, 6, right? So I can just define an array that is going to be filtered points before I for I in, sorry, 1, I1 for I in range, length of filtered points before. And we'll see the edge cases and the problems we can get after. But here, the idea is we can just paste the algorithm we had, right? That I closed and I shouldn't have closed. And let's check our submission. We had written this, right? Let's just copy this and just paste it. Paste it here. Where am I? Sorry, yeah. And we answered before is basically we're calling this function on this new array, right? And we'll do the same for the after points. Now there's one problem, right? There's one problem I haven't talked about is what if I have 4, 4, 4, 6, and 5, 8, right? I sorted through with regard with x, and now I only look at y's. And I could say, well, the longest subsequence is 4, 6, 8, and the longest subsequence is 3, so my answer is 3. Well, unfortunately, I'm not allowed to take those 2 points, right? With regards with y, I'm allowed, but with regards to x, I'm not allowed, right? Because those are the same values. So for a given x, that's the kind of hard part of the problem. For a given x, I'm only allowed, one y. And we have to fix that. And one way of fixing it is, instead of just sorting it with regard with x, we are going to sort it with regard to x increasing and with regards to y decreasing, Why? Because if we do this in this example, instead of having 4, 4 first, I'll first have 4, 6, 4, 4, and then 5, 8, right? And because the y's are decreasing for a given x, well, if I pick 6, I can't pick anything after 6, and everything that's after 6 are the y's that are smaller than 6, 4, 4. So I'm not, I don't have the problem anymore. I can just go there and I'll return to it. Hope that's clear. Maybe looking at more examples will help you understand. So the only thing I have to change here is the key of my sorting function, right? And minus xy. And I can just copy this. I'm filter after, this is filter points after I. The y, sorry, and this is ons after. Yeah, sorry, that's it. So that should be fine, and then I can just return, right? Return ons before plus 1 because I go through k, and then plus ons after. And the only thing is, well, if this is, well, this is, you know, my IDE is complaining, well, because ons after can be undefined, so I just have to initialize it as 0 here. Ons before, that's 0 here, and hopefully if I just paste the test cases, what's the name function I should expect for, no, I'm copying the wrong, yeah, sorry, I'm copying the wrong test case. Then I should have 4. Let's see what I get. The wrong answer. That's amazing. Let's find the error. Oh, there's no error. Yeah, the output is 3. The expected output is 3. Okay, now I don't have an error, and I can try to submit, and hopefully the answer will be correct. Let's just test on the few test cases that are here. They're accepted, and I can submit. Wonderful.